Hello guys, in this video we're going to be looking at some quadratic inequalities, and the first one that I'd like for us to look at is this. X squared is less than 25. Now a common mistake is to simply just square root both sides and say x is less than 5. Now that seems very logical, however, let's take a value of x. So let's take the number minus 6. It obeys the law of x is less than 5. But what happens if you square it? Because looking back at the first line, it says x squared is less than 25. So let's square it. If you square minus 6, that's 36. And 36 is not less than 25. So there's a problem. So we need to change our approach. So what we need to do instead is whenever you see a quadratic, we want to always compare that quadratic to 0. So anytime you see an x squared, basically. So if I take away 25 from both sides, I'm left with x squared minus 25 is less than 0. Okay, now at this stage, I want to imagine, let me just imagine that x squared minus 25 were equal to 0 for a moment. This is us looking for our critical points, as we call it. So here I can solve by factorization. And as we notice, it's a difference of 2 squares. So that becomes x minus 5, x plus 5 equals 0. So over here as well, I'm going to factorize to x minus 5, x plus 5 less than 0. Okay. And now looking back on the right-hand side, we have x minus 5, x plus 5. Now, the critical points there would be x equals 5 or x equals minus 5. And we're going to use that information to draw a sketch to determine our regions for which this is satisfied. Okay, so over here, I have my graph. Because it's a positive x squared graph, it's going to look something like this, where this point here is minus 5 and this point here is 5. Just a rough sketch. And now the next important thing, we pay attention to the fact that it's saying x minus 5, x plus 5 is less than 0. Okay, that's really important, the fact that it says less than. So because it's less than 0, we must look at the point or the bits that are below the x-axis. Okay, so our x-axis is here, and we're interested in this region here. Okay, so if we look at that really carefully, what that's telling us is that we're looking for when x is not only less than 5, but also greater than minus 5 at the same time. Okay, so the way in which we write that is like this: minus 5, x in between, and we say less than. Okay, so now we've not only got that x is less than 5, but we've also got that it's greater than minus 5. And that's how you would solve this type of inequality. Okay, let's just look at one quick example. So if we look at the example x squared plus 7x is greater than 12 or greater than minus 12, we then have that x squared plus 7x plus 12, remember comparing it to 0, so I'm going to say this: x squared plus 7x plus 12 is greater than 0. Okay, and then at this stage, I'm just going to say, I can factorize this and say that x plus 4, x plus 3 is greater than 0. Okay, and then having done that, I can now draw my graph of x plus 4, x plus 3. Remember, you must always sketch your graph for all quadratic inequalities. And if this were equal to 0, then the critical points would be x is minus 4 and x is minus 3. So, and because it's a positive x squared graph, it's looking something not like that. It's going to go through minus 4 and minus 3, so like this. Minus 4, minus 3. Okay? Now again, pay very close attention to the fact that it says x plus 4, x plus 3 is greater than 0. Okay, because it says greater than 0, we're now interested in the bits that are above the x-axis. So that's over here and here. Okay, that's all above the x-axis. So we must be very careful. Okay, and that having been said, we're interested in the bits where, well, x is less than minus 4 because it's to the left of minus 4. So we say x is less than minus 4, or when x is greater than minus 3 because it's to the right of it, x is greater than minus 3. Notice how with this one, it's two separate inequalities because it's impossible for something to be less than minus 4 and greater than minus 3 at the same time. So we have to write them as two separate inequalities. Okay, and that's it.